All right, the next two things that we do is we find our y-intercept. Now, had you distributed this, your y-intercept would just be your constant term. Well, can you get that without distributing? Yeah, we know that to find y-intercept, you just evaluate for x equals 0. So you plug in 0. So plug in 0 here, and here, and here, and here, and you're going to get, let me do that quickly in my head, 18,144. I didn't do that quickly in my head. I did it a long time ago. But that's why we're not graphing this. So our y-intercept would be 0, 18,144. That's like way up there. And this is the reason why most of our sketching is based on fairly simple things, because you just can't graph that, at least not very accurately. And that's not even the highest point on this graph, most likely. You'll probably have something higher than that it'd be impossible. So we're not going to do that. The main idea on this particular problem is to get how to find the leading term, what that is used for, how to find the y-intercept without having to distribute in order to find those two things. And then to take our x-intercepts and understand what they're doing. So let's move on to that right now. Our x-intercepts are found for basically every function by setting that function equal to 0, which is really convenient if we have it already factored. And that's great. So when we set this equal to 0, we can now use the zero product property. And what we're going to do is we're just going to set every factor that has a variable in it equal to 0. Now listen, your coefficient makes no difference as far as your x-intercepts. It does not matter. So you never set this coefficient equal to 0. It doesn't have a variable. It's not going to change your x-intercepts. All that does is stretch out or compress your graph and possibly reflect it. That doesn't make any change on the x-axis, because when you reflect about the x-axis, your x-axis doesn't change. It's just kind of rotated maybe, but that doesn't change the value. So you don't have to worry about that. So take every factor that has a variable in it and set it equal to 0. Let's do that now. That's what the zero product property says. So once we've done that, we have some basic solving to do to find our x-intercepts, like x equals 7, and subtract 1/2, x equals negative 1/2. If we subtract 4, x equals negative 4, and wait a minute, x squared plus 9 equals 0. Well, wait a minute. If I subtract 9, I would get x squared equals negative 9. If I take a square root, that's going to give me a complex number. If you think about it more closely,